Hey, hi friends. I know it's been quite a while now. I have not been able to post any blogs on my channel. Life has been really cruel and it's been keeping me on my toes for a long time now. Anyway, so today I thought to take some time out and discuss a case. We have over my channel seen database administration, development, MSBI. We have seen how to draw intelligence and do data visualizations as well. Seen a couple of cases. From here on, what we do is we take it to the next level of analytics and machine learning. So I mean, that's where the world is drifting towards now, and that's where a database and a business intelligence guy should be thinking towards. So let's discuss a very small case of business optimization and formulation of an inventory. This is a very small case. I call it V Kitchen. So the case description is something like this: a small and medium business organization, let's call it V, essentially cares about its employees' health and hygiene, and what they have done is they have come up with their own in-house kitchen preparation for the food, and they offer subsidized food to the employees. The cafeteria facilities have so far been very successful with this endeavor of providing hygienic food, but the problem is with their kitchen inventory management and optimization. So what looks like is for the case, the org strength is suppose 1,000 employees and the attendance is varying normally. It's under a normal distribution of 950 mean and 50 standard deviation. So amongst the employees who come out to work on each day of the week, 25 to 35% of the employees get their food from home, which means that they are married and have a regular normal life. Food is usually prepared and served in two categories in that organization. There is a vegetarian and non-vegetarian combo meals. The ratio of each of them is as per this table. For each of the days it varies across the day. So on Monday, let's say it's 7:3 between the veg and the non-vegetarian meals that is prepared by the kitchen, and so on and so forth. Now what we got to do is we want to forecast and predict what is the right number of veg and non-veg meals which needs to be prepared by the kitchen for the organization, for the employees, so that we can minimize the wastage of the food. So overall, let's say the case summary looks like this. Employee strength is 1,000 employees. Employee attending varies between 950 with a standard deviation of 15, and the percent of employee getting food from home varies with 25 to 30%, and the ratio of split is as per the table. The case objective says optimize the solution and develop a model to predict kitchen's expected daily inventory. That's all. So now I would be switching it to my Excel. So I have just consolidated all the points. What we have here is employee strength is 1,000, attendance is 950, has a mean and a standard deviation. So we'll be using at risk to optimize this solution. So I start with it. Let's say I would like to define my distribution. I say normal, select the distribution. I would say that's my mean distribution, 50, and the standard deviation of the variation is 15. I say okay, and then the food out of which the employees who actually come on to work, they have 25 to 30% of them get food from home, which is an uniform distribution. So let's define that. Okay, so we have a range here, so we say 0.25, sorry, 0.25 and 0.30. So that's the range. Now we have employee who get food from cafeteria. So for employee who get food from cafeteria would be essentially this *1 minus the value that we are getting, because these guys get food from home, so 1 minus that will be the percentage of people getting buying the food from the kitchen, and then the attendance multiplied by that. So that would be the number. Now I have split the table. The table shows the value of the ratio between veg and non-veg split. And next we would like to simulate the model here. So let's start with that. So the value for Monday would be 5. So employee who get food from the cafeteria into the value divided by 10. So that would be the value for your vegetarian number of meal packs for Monday. So star divided by 10. So that would be my value. So I take the same, and then we define outputs. Sorry. Okay. So I'm gonna add all those outputs. Right, so we are done. So at risk we are going to get all the outputs, and then we start. Let's just check on the simulation settings. So seed is fixed, and the value is 1 for initial. Yep, you're all set. Let's start simulating. Okay, perfect. So now let's we've got the results. Let's review each of them. So currently what we are pointed out towards is Wednesday for non-veg. That's the number of meals that should be prepared. So let's say 275.5. That means let's say 276 would be the right number. Likewise, Thursday. So as we scroll, we get the range and the deviation, the mean value and the standard deviation for each of the outputs for each of the days that needs to be prepared. So yeah, you can transverse across and get the exact value. So now if I close this, you can see this would be my number, and that would be the model I have built, and this would give me the exact number of meal packs that needs to be prepared across the week with this distribution, and the number of people attending the office and getting food from the cafeteria. So this helps a quick optimization for the cafeteria food. So that model is a simple template, or a simple example how we can optimize a solution. uh, that's just I've just got started with the new topic, and so on and so forth. We'll start to look towards machine learning and predictive analytics. I hope you've enjoyed this. This is just a comeback video to set the tone of the next to come. uh, Thank you guys, have a great day, see you around.